Hello everyone, welcome you all to the 14th session of Exploratory Data Analysis. I am your instructor Anup, and today we are going to understand the concept of box plot and whiskers. So now we have plotted histograms and PDFs earlier, right? So let me first take you to the PDF and histogram that we have plotted earlier, and let me show you something. So this is the histogram and this is the PDF that we have plotted earlier. And just by looking at the histogram, one problem that you will realize that, let's say for setosa petal length, I don't know what is the 25th percentile value. By just looking at this, I don't understand where the 25th percentile value or the 50th percentile value or the 75th percentile value lies. So while histograms are very good to understand the density of how many points exist at each one of the intervals, where it still can't answer the question, what is the 25th percentile? It still can't answer the question of, let's say, 25th percentile, 50th percentile, 75th percentile. So by looking at the histograms or at PDFs, we do not get any idea about the 25th percentile, 50th percentile, and 75th percentile value. Fine. And these percentiles are very useful, right? Because if I know what is the 75th percentile value, I know that 75% of points are below that. Of course, I do agree with you that we can solve some of the problem partially by looking at CDF. So let's look at CDF. Because if you look at the CDF, and if you want to calculate the 25th percentile value, so let's say this is somewhere 30, this is 25th will comes this point somewhere here. So if I join, let's say this point here, roughly if I join this point, it will come somewhere around here. And if I join somewhere, so my 25th percentile value, I will get somewhere between 1.3 and 1. Of course, we can get the percentile value from PDF. I completely agree with you. But there are other plots that can clearly give us that without having to draw these vertical and horizontal lines on PDF. Or no, on CDF, not PDF, on CDF. Such a plot is called box plot, and box plot uses the concepts of percentile. So again, drawing box plot is very, very simple. Let's write a code to draw the box plot. So Cboard gives us all the tools that we require to plot the box plot. So let me write the code first, then I will explain you. Write SNS dot box plot, BOXPLOT plot, and then inside this, as x, pass x is equal to species. I want to pass x is equal to species. Fine. Thereafter, y, pass y is equal to petal length, PETAL underscore length. Fine. Then let's pass data is equal to IDs data. Thereafter, there's one more parameter called hue. Let's pass hue is equal to, that is color. SPEs, here I want to color it by species. Fine. Thereafter, in the next line, let's write PLT dot show. So what I have written here, just you have to say SNS dot box plot. Then you have to say that your x-axis is species, which is basically setosa, versicolor, and virginica, and on the y-axis is the petal length, and your data set is IDs, and hue, that is you want to color it by species. And you just say plot plt dot show. It's a very simple one-liner to get your box plot. Now, if I run this code, so I'm getting this box plot. Let me open it in a separate window. So let's read this box plot and understand what it is. So you have three types of flowers. Your species, you have setosa here, versicolor here, and virginica here. And your y-axis is your petal length. And let me explain you how each of these boxes are drawn. So this is, if you look at this box plot, this horizontal line here at the middle is basically my 50th percentile. So let's put this horizontal line here. This horizontal line here is basically my 25th percentile. And this horizontal line here is basically my 75th percentile. So this is my 25th percentile. This is my 75th percentile. And this middle line is my 50th percentile. 50th percentile. So in this case, what we have done is we have broken the plots into three parts. And this width here has no significance. Let me write it. This width has no significance. Only this width has a significance because it is giving me the percentile value. So if you look at this box plot, this is my 25th percentile, this is my 50th, and this is my 75th percentile. I will keep on repeating these things. So this I have done for versicolor. This corresponds to 25th percentile of virginica. This corresponds to 50th percentile of virginica, and this corresponds to 75th percentile of virginica. Let's see why this is immediately extremely useful. So suppose if I set a threshold, suppose if I set a threshold, and let's say I'm setting the threshold at 0.5 at this point. Fine. So what it will do, I will use 5 as, if I use 5 as my threshold, and suppose if I write my rule like this, if else condition. So what if I will write, if petal length less than 5 and petal length greater than 2, then versicolor. Let's say this is my first rule. Let me erase this. Fine. So if I say my petal length is less than 5, petal length is less than 5, and petal length is greater than 2, then let's say versicolor. Fine. If I write this rule, and after that, if I write another thing, that if petal length greater than equal to, let's say 5, then virginica. Fine. Suppose if I set this right, then we know by just looking at this plot, I can tell you what type of errors we will make. So here, let's assume I set my value, threshold value at 0.5 as 5, and 5 is roughly, and 5 is roughly around 25th percentile value for Virginica. This 5 petal length 5 is roughly around, not exactly, roughly where the 25th percentile value of Virginica is, right? So this is the 25th percentile of petal length. This is the 25th percentile of petal length for Virginica, which are less than 5, So as soon as I write the if-else condition like this, I'm going to have 25% of my Virginicas labeled as versicolors or classified as versicolors. So when I have this rule, I can quickly read it from this plot that I'm going to have 25% error. I'm going to have 25% error. Why 25% error? Because 25% of points which are actually Virginica are going to be classified as versicolor if I have these two rules over here. So this is very, very useful. Let's look at it. Also, it doesn't tell me what is the 30th percentile or 40th percentile or let's say some other percentile value, but it's fine for me because we couldn't, the information, the data that I'm getting from this plot, from this box plot, we couldn't get the same information from my PDF or histogram, right? That's a big use case of your box plots. Now, I might ask, what are these lines? These lines. What are these lines? What are these lines? So let's understand these. What are these lines? So we understood the box part of it, but what about whiskers? These lines are called whiskers. So let me write it here. Whiskers. So let me explain you what these whiskers are. You might have seen cat or maybe dog also, or some other animals which is having a hair like this. Even you see this in case of tiger or lion kind of thing, leopard, you will see. So this hair kind of thing is called whiskers. You can generally see these whiskers in case of cat because cat is readily available everywhere. So you can see it. So look, so cat has this whisker. So this whisker is coming from cat. So these are called the whiskers of a cat. And let's understand what this whiskers mean here. So these lines are basically whiskers. These lines that you are seeing here are basically whiskers. Now, there is no standard way on drawing these whiskers. One way that people draw whiskers is people say, let me take the maximum value, max value, let's take the max value, let's take the minimum value, and then let's draw the whiskers. Because in a single plot, I know where is the 25th percentile, where is the 50th percentile, and where is the 75th percentile. Where is the maximum value? Where is the minimum value? Let's say this is my, I assume this is my maximum value. This is my minimum value. Fine. This is my minimum value. So one way of drawing whiskers is using min max value. Min max value. This is one approach of drawing whiskers. So basically, this is the minimum value of petal length for versicolor, and this is the maximum length. I think Seaborn doesn't use the min-max approach. So Seaborn say, I will draw my whiskers, and again, there is no standard way on drawing whiskers. What Seaborn say is, I will take 1.5 times IQR. 1.5 times IQR. IQR my interquartile range. I know what is my IQR. IQR is nothing but the width of this 75th percentile and 25th percentile. This is, let's say, my IQR. So this Seaborn says, I will use this approach 1.5 times, 1.5 times IQR to calculate. I think Seaborn uses a slightly more complex mechanism, because if you notice, let's say here, this length is not same as this length. Even this length is not same as this length. This length is not same as this length. So Seaborn uses a more complex mechanism on coming up with whiskers. But there is no standard way to draw whiskers. One simple way is to put it at min and max. But one thing that I can quickly get from this plot, which I couldn't get from my PDF plot or CDF plot, is if I put a threshold at 5, how many points are above and how many points are below? How many points are above and how many points are below this threshold? I can get this. Now, there is another way to look at it. If I look at this data this way, because let's say this is my 75th percentile, let's say this is my 50th percentile, and this is my 25th percentile. So I can imagine that this is the width in which 50% of my, this is the width in which 50% of my points. So your whiskers are typically drawn in such a way that most of your points actually fall within your whiskers, whatever way you do. So your whiskers are drawn in such a way that most of your points fall within your whiskers, these whiskers. Here, majority of your points will lie here, but this is low, like most of your points will fall within your whiskers, whatever way you do. If you do min-max, all your points lie here. But even if you use slightly complicated method of drawing whiskers, you know, most of your points will lie here. But if I put this threshold as my 5, I'm going to have 25% of errors. So box plots, taking the ideas of mean, median, and quartiles and putting it into one platform. This is all for the day. See you in the next session. Till then, keep learning, keep smiling. Take care. Bye-bye.